Hello, beautiful stats people. Welcome to our first official lecture of statistics, where we're going to take a little look at where statistics starts from in a chapter that I call Stats Starts Here. So main learning outcomes for this chapter are understanding the difference between statistics, so what that is, what data is, thinking about data collection and the different types of variables that we're going to be working with this semester. So as a kind of, I guess, general overarching idea, statistics is essentially the study of how to collect your data in the best way, analyze that data, and trying to draw conclusions from that data that you have. So main goals for statistics, first and foremost, how do we pose a good question? After we figure out how to pose a good question, we then try to figure out how to collect that data as best we can. And then after collecting that data, we look at how to formulate conclusions. So there are certain ways that are, I guess, more acceptable than others when it comes to collecting that data and drawing conclusions from that data. Now, these chapters are going to be from the old textbook that I used to use, but we're still going to follow a very similar overview for our course. We're still going to be looking first and foremost at how to pose questions and how to collect data. Once we have answered those preliminary kind of questions, we're going to then turn our focus into how can I work with this data. So a lot of what we do after chapter 1 is how to work with displaying that data, so different kinds of plots we can work with and different visualizations. After we're comfortable working with different kinds of variables and different data sets, we're going to take a look at probability. So probability forms kind of the core of the conclusion section of statistics. So we want to learn how to utilize probability in order to draw out the best kinds of conclusions that we can. So the last typical section that we kind of work with in statistics is learning how to test claims and how to make conclusions from the data that we have collected. Now, data is coming at us in a wide variety of ways all the time. So, for instance, back when I used to actually upload frequently to my YouTube channel, I had all of this data in Google Analytics. So, for example, in the top kind of left here, we have a little pie chart that has different kinds of ways that people found my YouTube channel. So either a direct search, which would be directly through YouTube, organic searches, which happen via Google or Yahoo, if people still use Yahoo. Referral would be if I had put a link or something into an email and then person clicked through that link to get to my YouTube channel. And then social would be something like a Twitter account. Maybe I was tweeting out something and someone would have clicked on that link and came in via Instagram or Twitter or Facebook or something like that. To the right of this pie graph is what we call a temperature graph. So the temperature graph here shows us where people were visiting from. So for instance, you can see that it's much darker blue, for instance, here in Canada, because a lot of my views would have came from Canada. But notice that there were several views from maybe the United States and some various views from all around the world as well, which is kind of interesting. So interesting to see kind of a different way to display the number of hits that we're getting from around the world. And of course, at the bottom shows a lot of different kinds of analytics. So showing page views, for example, over the last several years, between 2015 and 2017, you can see kind of a sharp decrease over these couple years as I stopped posting content readily or frequently. And of course, different page views, average time people spent watching videos, etc., etc. Now, what we want to kind of think about is, we have all of these visualizations, we have all of this data that's in front of us. We want to actually be able to go through and, I guess, categorize the different kinds of variables that we want to work with. So if we're talking about data is essentially a plural word. So we're talking about more than one piece of data. So a datum would be a single piece of data, just for your reference, and data is actually technically a pluralized word. And what happens is when we go to collect data, these data sets that we get always exhibit a little bit of variability. So for instance, maybe if I'm looking at a different time period when I'm going to collect data on how people are coming into my YouTube channel, these percentages in the pie chart might be different from time to time. This is what we mean by variability. So there's potential that if I run the same kind of experiment or ask the same question 2 different times, the data sets that I could get might be a little bit different from each other. So this is what we mean by variability. And because data sets exhibit this idea of variability, the items or the things that we're going to be talking about in statistics are called a variable. So let's discuss, I guess, the main kinds of variables that we'd like to talk about in our course. The first one is called a categorical variable. And a categorical variable is any kind of variable that we go to collect information on, and the information that we collect, we can't really perform numerical computations on. So think of something like if you've ever answered a survey and that survey has asked you whether or not you are male or female, the person organizing that survey would have all of this information on how many males answered this question, how many females answered this question, or maybe people that were impartial to that question as well. And so we essentially have like a count of the number of males, number of females, and number of people that don't agree with either of those titles. Pardon me. And we can't do a lot of numerical computation on this. I mean, we can essentially look at what's the proportion of males that answered this survey, or what's the proportion of females that answered this survey. And that's really as far as we can go with something like a categorical variable. Now, that's okay. I mean, categorical variables tend to lend themselves very nicely to things like pie graphs, like you see here at the bottom, because those proportions often can get put into percentages. And that's typically the main analysis that we use for categorical variables. So if it's something where we're kind of counting the number of things, or kind of categorizing something, like putting it into kind of separate bins, that's typically a categorical variable, and we're typically doing what we call proportional analysis. We're looking at the percentage of this thing, or a percentage of this thing. So some other examples here I have on the slide: marital status, married, common law, single, in a relationship. It's complicated. That kind of stuff, right? We're kind of sorting people into different boxes. We can count the number of people in those boxes and do a proportional analysis on that kind of stuff. Now, categorical variables do have some subtypes. So the first type of categorical variable is called an ordinal categorical variable. Now, ordinal just means that there's an order to it. Ordinal order is how I remember this one. And I've put an example up here on the slide of some questions here. Like if you're doing, this looks like a maybe end of semester questionnaire to describe how much you loved this course. And you'll notice those kind of end of semester questionnaires have like little titles over here on the side, like always, often, and rarely. So what we're doing is we're kind of collecting the number of students that select always for question 1, the number of students that select often, and the number of students that select rarely. We can't really do numerical computations other than break this down as a percent. The percentage of students that say always, the percentage of students that say often, or the percentage of students that say rarely. Notice that the way we've broken this collection down is always, often, rarely. And those words inherently have some kind of order to them. It wouldn't be like male or female. So something like male or female doesn't really have an inherent order to it, but something like always, often, and rarely feels a bit more structured, a bit more ordered. So all of the questions in this particular questionnaire would all be categorical, and they would all be ordinal. They all have some kind of order associated with the responses that we're getting from our students. Now, the other kind of categorical variable we work with is called a nominal categorical variable. And a nominal variable, nominal really just means it has a name. So there's no order associated with this kind of categorical variable. And the best we can do after we collect the data is to do some kind of percentage or proportional analysis. So for example, I have put here, let's see, the number, or I guess percentage of Canadian users of Facebook, LinkedIn, Twitter, and Instagram. So we look at all of the people that use Facebook, and about 59% of them are Canadian users. Or we look at all the people that are on LinkedIn, and about 30% of them are Canadian users. So that's what this graph here is showing us at the moment. So notice that we have some kind of proportional analysis happening. So this tells us that we would be working with some kind of categorical variable. And notice at the bottom, this is kind of that variable that we're working with. I guess the social media platform might be a good way to label this variable. Facebook, LinkedIn, Twitter, and Instagram. Those are our social media or connecting platforms. There's no real inherent order in this, although, I might argue that Facebook might be at the bottom and perhaps like Instagram's actually at the top. But anyway, this is an old bar chart anyway. But notice that there's no real order. At the bottom here, we just have the social media platforms, Facebook, LinkedIn, Twitter, and Instagram. It's a categorical variable without an inherent order to it, so we call it a nominal categorical variable. Excellent. So the next kind of variable that we're going to focus on working with this semester is called a quantitative, or sometimes called a numerical variable. And when we go to collect this data or collect data on these variables, what we are going to get is something that we can actually do computations with. So when I say do computations with, I mean find an average, for example. Find the mean, the median, or the mode, for example. Find what we call the standard deviation, if you've ever heard of that before. So these kinds of variables, because they're numeric, they actually come with associated numbers that are easy for us to work with. We can actually do some more thorough kinds of analysis on these kinds of variables. Often your quantitative or numerical variables will have units. And that's usually kind of a key giveaway that we're working with a quantitative kind of variable. So a couple examples here, like age in years, measurement in centimeters, longevity in hours, a couple examples. And like I said, often when we get these kinds of variables, we're interested in an average or a standard deviation analysis, where what we usually do is we call this looking for the center of our data and looking at the spread of our data. And we'll talk a little bit more about that as we get into more thorough analysis with the mean and the standard deviation. But just kind of like looking, I think I circled down here at the bottom, average time on page. So notice here that this is coming as 2 minutes and 24 seconds. So this would be an example of a variable that has an associated unit. It has a time unit associated with it. So as people come to this YouTube channel and watch a video, YouTube will keep track of how long they've watched that video and record that time. So that would be an example of a quantitative kind of variable. I'm getting a bunch of different longevities, I guess, for how long people are watching those videos. And we're doing an analysis that involves an average. So that's kind of another key giveaway that we're working with a numerical kind of variable. I have units of time, and notice that Google Analytics is showing me the average time on page. Okay, so an average is something that we can do with a quantitative kind of variable. Now, our quantitative variables can also come in two different subtypes. The first subtype is a discrete quantitative variable or a discrete numerical variable. And essentially this is numbers that will take on kind of a more of an integer value. For example, if we're describing our age, generally we describe our age in years, unless you're a baby for some reason, in which case parents are always like, they're 37 and 3/4 weeks old. Like, who cares? Like, are they 1 yet, or are they 2? Like, how old? Like, don't tell me that they're 36 months. I kind of want to do mental math in my head. Just tell me that they're 2.5 years, right? So most of the time after we've, grown up a little bit, we self-report our age as an integer value, a discrete value in years. We don't usually tell people, I'm 21.7 years old. We don't usually do that. And we especially don't usually do that when we're filling out paperwork, say for the government or something like that. So I think that's a good example of a discrete quantitative variable. There's also a little line diagram or a line plot kind of given down here for you, where we're breaking down average income amongst different lawyer types of different ages. So you can see that age breakdown on the bottom, age 25 to 29. Usually those are kind of discrete years, for example. And then over on the left-hand side, we have an average income in dollars. And notice again that some of the ticks that we have here are in the nearest like $1,000 or nearest $50,000. So we could almost think about this average income likely as a discrete variable as well, because most people will round their yearly income up to the nearest $1,000 usually. So just a couple different examples of what we call discrete numerical variables. Now, it's possible that we have a more continuous kind of numerical variable that we work with as well. And I think about the difference between discrete and continuous in terms of whether or not I'm using whole numbers or whether or not I'm breaking the whole numbers down even further into a decimal kind of number. So essentially, anytime I'm working specifically with something like dollars and cents, that would be a more continuous kind of variable. But if I'm working with something like rounding to the nearest dollar, that's more of a discrete kind of thing. And it could potentially be argued you're going to notice that as we start to actually chat a little bit more about these things, the way that you collect the data also kind of tells you what that variable looks like. But in general, if it's an integer or whole number, it's probably discrete. If you're going down to the nearest kind of decimal place, like 1 or 2 decimal places, I'd probably list it as a continuous variable. But there's a little bit of flexibility depending on how the data collection is actually set up. But I did want to give you, I think some of you might be in the business stream and taking this from the business perspective. I know I'm going super old school here, but this is what I would fill out to do my income taxes. And you can see there's a couple of spaces here that have like a little dot over on the right side. So for example, line 222, it says deduction for CPP or QPP on self-employment and other earnings. I'm not going to tell you what that means, but I do know that because that dot is there, Revenue Canada expects me to report that to the nearest cent. So rounded correctly to 2 decimal places. So I would consider line 222, line 223, and line 235. These are continuous kinds of data that I'm giving to Revenue Canada when I'm doing my income tax. All right, so I have, I guess, a little kind of questionnaire here for you to take a look at and think about and see if you can figure out what kind of variable we're working with. And what we'll do is we'll start class next time. So our next live class, we'll actually go through these 3 together as a little review of this lesson. So the first one I want you to take a look at is how many online courses have you taken in the past? 0, 1, 2, 3, more than 3. So take a few moments, to think about whether or not you think that's a categorical variable, whether or not that's a numerical variable, and try to figure out what subtype you think it is. So if you think this is a categorical variable, is it ordinal or is it nominal? If you think this is a numerical kind of variable, is this discrete? Is it continuous? And do the same thing for the next two as well. How would you rank your technology skills? And how would you rank your interest in US history? So do that over the next couple days. You might just kind of briefly jot it down into your notes right now. And like I said, we'll do a quick review on this during our next live class. So the 5 W's and 1 H of data collection are as follows. I mean, there's not a big surprise here, but what I do want to do is just kind of briefly touch on these, and this is kind of our jumping off point into the next live lecture that we're going to have. So it's basically who, what, when, where, why, and how. So who, of course, refers to the people that we're going to be interviewing or collecting data from. So who are those people? And trying to get a better handle on different groups and subgroups of the people that we're working with. What refers actually to the variables that we're going to be collecting. So am I doing categorical collection, numerical collection, and trying to break down those variables even into their subtypes if it's appropriate. When, of course, refers to the time frame of the study. Where, of course, refers to the location of the study. Could be online, could be in person, could be mail-in, could be over the phone. So there's lots of different possibilities for where. Why is kind of the big question, like why do I actually want to collect this data? Am I trying to do this or trying to do this? And we'll talk about different kinds of studies and how that affects the why portion of the 5 W's and H. And of course, one of, I think, the most important ones here is how, and that's the methodology. So how am I going to collect this data, and how am I going to ensure that the way that I collect this data is ethical and non-biased? So like I said, we're going to flush these out in a little bit more detail during our class next time. So for now, you can generally ignore the to-do lists at the end of these chapters. But one important thing to do at the moment is purchase your calculator. And if you want to buy a copy of the textbook, you're going to want to do that sooner rather than later as well. Other than that, that is a little brief introduction to our statistics course for this week. And I will see you in our next live class starting next week on Tuesday. All right. Thanks, guys. Talk to you later.